Hi everyone, we're going to solve these quadratic equations now by completing the square. We're going to go over a couple different things in this video with vertex form, completing the square, and all these different things. Not every little step you'll need to know how to do to solve, but they're just important steps that you'll need in order to actually see it in vertex form. What I always suggest for these is to get the quadratic equation equal to 0 first. That usually is the easiest place to start. If you don't already have it equal to 0, get it equal to 0 first. Luckily for the first two, they're already equal to 0. So we can start right with the first one right off the bat here. So what you could do is look to see, could you factor, right? So we look to see at this quadratic, can we actually factor this? Can you multiply something to -1 and add those two numbers that you multiply -1, can they add to 2? And there really is no way to do that, because in order to get -1, it'd be 1 and -1. There's no other option to get you -1 as a product. And these don't add to 2. So pretty simply we can see we can't factor this problem. So the easy method is out of the way. So let's try this completing the square method. Here's how I always look at this. I want to think about this quadratic as if it were a square. Let's call it completing the square. There better be a square that we're actually completing. So what we often do is say we've got like x plus 2 and x plus 2. That would be a square, because the same thing on both sides. So then you could just figure out the areas using that. I'm actually going to write this a little backwards though. I'm going to write it like this. So then x and x would make x squared. This would be 2x, 2x, and 4. That would be the area model for finding the product of x plus 2 times itself. So we're actually going to do that backwards. We're going to figure out the square by looking at the pieces, and then that'll help us figure out the length and the width. But we're not going to have these numbers. I just kind of made those up just for an easy example. But we are going to have the square. Let's copy that for later use. Okay, so what do we have here? Well, we've got an x squared, so let's put that here. Okay, how do we get an x squared? X times x. Okay, that part's the same. But then we have two x's. So now in the example I had before, that was 4. We have two x's. In order to be a square, I can't put some of them here and none of them here. That's just not going to work, because then I've got different side lengths. This would be +2 and +0, which is a rectangle, not a square. So we can't do that. So what we end up doing here in order to make this a square is we take the x's and we split them up in half in each of those boxes there. Because this is x, if this is x down here, this is x up here. And similarly, this is x over here and x over here. So these boxes are going to be the x terms, x times something. So in order to split 2x into two equal pieces, it would be 1x and 1x. Okay, well that would be x times 1 and x times 1. And it's a positive 1, so we put a plus sign on it. Like that. Now, to complete our square, we're looking to see what goes in this box. That would complete the square. Well, if this is 1 down here, this has to be 1 over here. If this is 1 over here, this is 1 over there. And then we know what that little question mark has to be. It's a 1 times 1 area, which is, well, 1. So to complete our square, we need 1. So here's what we do. We're going to make this work now. We're going to take all of these pieces and put them together, because we know what that is. So we're going to write that right underneath our original equation. So we've got an x squared. We've got 1x and 1x, which is 2x. And we need a 1, so plus 1. I'm going to box that in because that was our square. So I'm going to write it in like square brackets to think that was our square. Those are all the pieces. So these pieces here correspond with all of those area pieces put together over there. Hopefully that makes sense so far. But what I've done is I've added in a 1. There wasn't a 1 originally in this quadratic equation. There's a -1, but there wasn't a +1. So what I have to do is I'll also subtract by 1, because I can't just add in 1. But then I'm also going to bring down this other -1 and the equal 0. So all I've really done to this problem so far is I've added in a 1 and subtracted out a 1 and added in some square brackets. Everything else has stayed the same. Make sure you understand that so far. So all I've done so far, basically, I'm going to erase some stuff and rewrite it. So here's the original. So all I've done is said, okay, we need a 1. I can't just add 1 though, so also subtract 1. And then I'm going to box in the area pieces that make my box, that make this square. Okay, so now let's talk about this. Well, x squared plus 2x plus 1. Sure, let's combine those two -1s together. Why not? Now, we know how to factor this, because it's right over here. It's x plus 1 times itself. It's a square. It's the length and width of this box, length times width. So we can write that in factored form over here. X plus 1 times itself is the same thing as x plus 1 squared. Now minus 2 equals 0. Now this is what we call vertex form. If you didn't need to solve the equation, we'd be done. This would be vertex form, where it's like x minus h squared plus k equals 0, with a little a in front typically. The vertex is hk. So the vertex of the quadratic would be the opposite of what's being added to h, or to x, and then the value of k. So let's move this out of the way for now. Looking at this, our vertex would be the opposite of what's happening to x, so it'd be -1, -2. We don't actually need that here in order to solve it, but that is true. That is true for this problem. Okay, let's move this, let's get rid of this, and let's move this over. Not that we need it, but it is true. Okay, now let's solve this problem. A couple more steps here to get this by itself. We want to get x by itself, so we're going to add the 2 over. I'm going to change this just to parentheses here just because it's easier to write, but it could be square brackets. It makes no difference. Now, in order to solve this, we're actually going to do a square root of both sides to get rid of that squared. But don't forget the plus or minus, because there's always 2 options for a quadratic, unless it's the same thing twice as a double root. So there we go. We got one more step to get x. Subtract the 1. So x is a -1 plus or minus the square root of 2. Now, you could have written it as plus minus square root of 2 minus 1, but be careful with that, because this little square root might go a little too far, and now you're wrong. So I usually don't write it like that. I usually put the -1 first, and then the plus or minus the square root. That way you don't accidentally write the wrong answer. And this is it. So your 2 options are -1 plus the square root of 2, and -1 minus the square root of 2. Those are your 2 possible roots. Okay, a little bit faster now for the next one. So again, let's think about this square. I think I had it copied. Let's paste that in. Oops. I did. See, look at that. Cool. All right, so now let's fill out this square again. So we've got an x squared. Well, that's x times x. We're going to take the b term. We're going to split it in half. So -7x and -7x, which would be a -7 and a -7, which means this is -7 and -7, which means the missing piece is 49. So I need 49 to complete the square. So I've got x squared minus 14x. I'm going to add in 49, but I have to also subtract it in order to keep it equal. Then bring down the plus 10 equals 0. That's still there. This was in the square, and we know how that factors. That's x minus 7 squared. Combine your numbers here. It's minus 39 equals 0. A couple more steps and we got this done. Plus 39. So x minus 7 squared equals 39. We can now do a square root of both sides. Just don't forget plus or minus. So x minus 7 equals plus or minus the square root of 39. Add the 7 and we are done. X is 7 plus or minus the square root of 39. 2 solutions. That's how we do it by completing the square. That's how we solve these quadratics. A little bit trickier down below here because it's not already equal to 0. So again, I suggest you always get it equal to 0 first. For me, that's always easier. So I'm going to do some moving of some pieces here. These two don't combine, so be careful. I'm going to put them side by side. They're not like terms. Okay, let's bring down our square. We've got an x squared, which is x times x. We've got 6 x's cut in half would be 3x and 3x. So a plus 3 and a plus 3 would make this 9. Which is kind of interesting because we already have it right there, which means this actually factors, which is really interesting. I'm going to pretend like that 9 isn't there just for fun, though. So this is actually, so I'm going to add in the 9 and subtract it, just again for fun. So x squared plus 6x plus 9 minus 9 plus 9 equals 0. So I added in a 9 and I subtracted it in order to make it work. So this is x plus 3 squared plus 0 equals 0. I'm writing it in this form because I want to see the vertex. The vertex is actually -3, 0, because that would be the y-coordinate. I think I skipped the vertex back here. Yeah, the vertex here would have been 7, -39 for the vertex of that one. The opposite of the x thing and the y-coordinate the same. All right, so now let's just solve this. So x plus 3 squared equals 0. Square root of 0 is 0. So x plus 3 is 0, which is actually just one answer, -3. So it's actually a double root, because it would have been this x plus 3 times itself. That's what it is with the squared. So it's actually just one answer here of -3. All right, one more example. Let's try and get all the x's. Let's try and get a positive x squared just to keep this easy. So positive x squared, let's add it over here. Let's subtract an x from those three x's and move the 4's. All right, so 0 equals x squared plus 2x minus 3. Just make sure I did all that correct. Those are gone, those are gone, those are gone. Okay, so now, again, let's put the little square over here. We've got an x squared, which is x times x. We've got a 2x, which is 1x and 1x, so a plus 1 and a plus 1, which means that's going to be a 1, because it's 1 times 1. So we've got 0 equals x squared plus 2x. We need a 1. We got to take away the 1 in order to cancel it out, and then a minus 3. We box in the pieces that make the area of the square. We factor it. That's x plus 1 squared minus 4. And then from here, we add the 4 over. We get 4 equals x plus 1 squared. We take a square root of both sides. Don't forget plus or minus. So plus or minus 2 this time equals x plus 1. Then we subtract 1, and we get our answer. X is -1 plus or minus 2, which means that this was actually factorable. We could have gone back and actually factored this, because it would have been x plus 3, x minus 1, in order to multiply to -3 and add a 2. Because this is really -1 plus 2, or -1 minus 2, which is 1 and -3, which is what you get if you just go back and solve this by factoring. So sometimes we can always use different methods to solve these. Even if it's factorable, we can use this completely squared method to find the roots. So it actually always will work, whether it's factorable or whether it's not factorable. I did skip the vertex. Let's go back and add that in here. The vertex here, because that's in vertex form, would be -1, -4 would be the vertex. And that's how we solve a quadratic, by using complete